Okay, in this video, we want to see if we can apply the method of synthetic division to try to factor out this polynomial here and express it in terms of its prime factors. We have lambda cubed minus 20 times lambda squared, so the power that this is raised to is 1 less than this, plus 23 times, or 93 times lambda to the first power, that's 1 less than this, minus 126 times lambda to the 0 power, that's 1 less than this power here. So we don't have to rewrite this. All we have to do then is write down these coefficients. 1 minus 20 plus 93 minus 126. And without any insights as to what the possible prime factors might be, let's just kind of start and just use a trial and error method. Suppose we wanted to find out, is lambda minus 1 a factor? And remember from the introduction video then, we write plus 1 here, and we write it down here, and then add and multiply. This looks like it would be minus 19, and times 1 is minus 19. 93 minus 19 is 74, and this would be plus 74. These do not add up to 0, which means there's a remainder there, so we can eliminate lambda minus 1. What about, say, lambda plus 1 then? Could that be a factor? So we want to investigate lambda plus 1, and now we write down negative 1 here, and we write it underneath the second number. Form this column and add and multiply, so this would be minus 21 times minus 1 is plus 21. Add these, this is 414 times minus 1 is minus 114. Those are not going to add up to 0, so don't waste any time. Eliminate this, and let's move along to our next possibility. Say, let's try lambda minus 2. So again, we write plus 2 here, and we write it here, add and multiply. This will be minus 18 times, this is plus 36. This here would be, actually this is going to be minus 36. And 93 minus 36, so this is plus 57. Multiply that by 214. Those do not add up to 0. Move right along. What about lambda plus 2? So here we write down minus 2. Here we write down minus 2. And add and multiply. This will be minus 22 times minus 2 would be plus 44. Add these together. 137 times minus 2, that's not going to be plus 126. I don't know what it's going to be, but it's not going to be plus 126, so that remainder is not going to be 0, so don't waste any more time. How about lambda, say, plus 3? Will that be a factor? So here we write minus 3, and here we write minus 3. Add and multiply, this will be minus 23 times minus 3, 69 plus 69. And let's see, this is 12. Let's say this is 162 times minus 3 is not going to give us plus 126. So don't waste any more time. How about lambda minus 3? We're just kind of moving on by trial and error here. Lambda minus 3. Now here we write down plus 3. This is plus 3. It looks like this would be minus 17. 17 times 3, 51. This would be minus 51. And 93 minus 51, plus 42 times 3 be 120 plus 6. Looks like that's plus 126. That's going to be 0, therefore that's a factor. Okay, finally. So now we can say that lambda cubed minus 20 times lambda squared plus 93 times lambda minus 126 will equal lambda minus 3 times what? Now we know what we did before. Take this one, bring it down, and in our original polynomial, this one was the coefficient of lambda cubed. Now it is the coefficient of lambda squared. This is the coefficient of lambda, and that's our new constant. So this is equal to lambda minus 3 times lambda squared minus 17 times lambda plus 42. Okay, now are there any prime factors that we can break this into? We're looking for two numbers that we can multiply together to give this, and add it together to give that. Minus 6 times minus 7 would do it, but those would add to minus 13. But if this was minus 14 and this was minus 3, that would give us plus 42, and those would add up to minus 17. So this we can write as lambda minus 3 times lambda minus 14. So finally, we can make a determination here. Our polynomial is equal to lambda minus 3 times lambda minus 3 times lambda minus 14. Okay, as you can see, it took a while to get there, but we're strictly using trial and error to demonstrate the utility here of synthetic division, and we'll try and prepare maybe a couple more videos that maybe have some other examples that might be even more complicated. So come back and join us for those videos, and we'll see if we can factor some more polynomials.